Hey everybody, I'm going to try to make some videos here again for you to help you if you're struggling or just if you want a pace that's a little bit more your own. So we're going to go through here. I'm going to split it up into I think 4 or 5 videos to see how it works out, and just take it at your own pace. Stop where you need, ask questions where you need, and hopefully this will work out for you. The unit we're on right now is solving linear equations. The main point of this is to be able to have 2 different sides to an equation and to find whatever your variable, whatever your missing thing is. So by the end, you should be able to do a few things. You should be able to balance equations with integers using opposite operations. We've already had a little bit of practice there, but it's going to get a little bit harder. Not too much, but you're going to be having some 2-step equations, and you'll be using the distributive property later as well. You'll be able to simplify things, expand equations, and definitely combining like terms is something you're going to have to know how to do. And you should also be able to model what equations look like pictorially. That means like with drawings, you should be able to show what that means. Alright, so we're starting off with just the simple stuff, the stuff that you're probably used to already, solving 1-step equations. You started to look at that in 7th grade, so it shouldn't be too crazy here for you. First, we're going to look at the anatomy of an equation, and what I mean by that is what this all means. There's a little space here. I'm not going to write everything, but I can tell you what goes in this spot. Equation. What an equation is just anything that is affected by an equal sign. Like that thing here. This whole bit is an equation. It affects everything. So 2x plus 3 equals 15. That is an equation. An expression. An expression is just the, well, you can look at it like the way you'd express yourself, right? You'd express yourself in a lot of different ways. In math, we represent variables with the x here. So 2x plus 3, this right here is an example of an expression. We're saying something with math. So is 15. So is 2 plus 2 and 7 plus 14. Those are all expressions. But when you combine them, when you combine 2 expressions with an equation, right here, when you combine them with an equal sign, it turns it into an equation. So this whole thing here, that's an equation. All right. So hopefully you can figure out in your own words how you're going to write that down, equation and expression. And you got pictures here. It says term and stuff too, and just think of it like each little block is a term, right? It's split up by a plus or minus, or on the other side of the equal sign. Those are all terms. Okay, moving forward. There are a couple probably new words here for you. You have the numerical coefficient. That's a funny word. We'll get back to it. Variable you probably know. Remember that a variable is just a letter that we can use to represent something that we don't know. So I could use anything. I could use U, I could use R, T, N, X, Y. I can use anything to represent, but you'll get used to seeing a lot of X's and Y's and Z later on in upper math. So get used to those ones. And remember, we're trying to get away from using times as an X because it gets real confusing when you see X's everywhere and times everywhere. So keep that in mind in the future as well. Constant. A constant, that's an easy one. Constant is just a number on its own. It's just a number that doesn't change. It's not affected by anything. So the constants here are underlined. And now I'm going to go back to that one that is a little bit tricky, the numerical coefficient. This is probably the one that many people are going to have problems with. The numerical coefficient is the number attached to your variable. And sometimes it can be a little bit disguised, as you'll see here. So we're going to try to go through here. Let's start off by just looking at our variables. Well, our variable in the first one, I'm looking over here, variable in this 7u minus 2 equals minus 16 is just u. So I'll write u here. In r over 2 plus 3 equals 17, that's just r. And here the variable is t. And in this one, our variable is x. Okay. Notice I didn't write minus x, I just wrote x because I only care about the variable itself. All right, the constant. The constant, remember I told you, is just the number on, well, look at the number on the side of the equation that has your variable, and that's your constant. So here we have -2, and here we have 3, and here we have 6, and here we have -1. Okay. And now we're back to the numerical coefficient. The numerical coefficient, I said, is the number attached to your variable. It's going to get a little tricky on some of the later ones, so try to see what I'm doing here. First one's not bad, 7u. The number attached is just 7, so my numerical coefficient is 7. Here, though, we have r over 2. Now, r over 2, don't make the mistake of just putting 2 because, you know, there's a 2 there. No, there's not a 2 there. The thing that's actually there is 1/2. You don't see the 1. It's kind of invisible because, you know, it doesn't make a difference. But it is 1/2 times r. That's what r over 2 is. So my numerical coefficient, the number attached to my r, is 1/2. All right, now over here we have t. Is there a numerical coefficient? Some of you might say no, and then put 0, which would be wrong. There is a number attached to my t, and that number is 1, because 1 times t is t. So my numerical coefficient in this case is 1. And now, because of the way I just did this one, you can probably figure out what I'm going to say here. Our numerical coefficient isn't minus, it's -1. All right. Now, moving forward to the next one, we have to identify the numerical coefficient, variable, constant, and the answer for this. Okay. Let's start off with our numerical coefficient, since we know what that is now. I don't think we should get into the answer yet. Maybe we'll come back to this one later. Or we can just simplify it. Let's just simplify it here. So what I'm going to say here is my numerical coefficient, there's a couple. There's this one, there's a 4, and there's a -6. I haven't shown you combining like terms yet, so all you're expected to know right now is that my numerical coefficients that I can spot are, well, I got this 4 right here, and here I've got a -6. Cool? It'll get a little more complicated after, but for now, if you can spot that, that's great. My variables, I have an x. So yeah, all right, we got x. And constants, well, I see a 9 here, okay? And what else do I see? I see, so I've dealt with this, I have a 9, and I have a -5. And just to simplify it, we're going to say our answer is the thing on the other side of the equation here. So it's 14 is the answer. This expression has an answer of 14. That's what I'm saying here. Hopefully it'll get a little easier in a second when we start to combine things. All right, move forward. Combining like terms is what I was talking about. Okay, simply here, without reading all this, like terms are things that are the same. That's why they're alike. So look over to the check mark. X and -x, they're alike. 2x squared, y squared, and 2x squared, y squared, they're alike. I mean, well, they're identical, so of course they're alike. 1 over 4x and x over 4, those are also alike. Remember, because this is just the same as x over 4. All right. Now I want you to look over at the x part, the not like terms, and try to see what the difference is between each of these lines. We have x and x squared. That's not like terms, and these ones were, but they both have x's. 3x and 3y, those are not alike. These ones both have x's and y's. How could that be? X squared, y, and xy squared are not the same. They do look different, but why are they not alike? And the answer comes down to these things, the exponents. The exponents are what tell you whether something is alike or whether it is different. In this case, it doesn't have an exponent, but it actually does. If there's nothing there, it actually means there's an exponent of 1. So x to the power of 1 is not the same as x to the power of 2, but x to the power of 1 is the same as minus x to the power of 1. 3x to the power of 1 is not the same as 3y to the power of 1 because they're different variables. This one, though, all the powers match up exactly, so they are the same. Here, x squared y1 is not the same as x1 y2, but x1 and x1, those are the same. So what you really need to care about is the powers, the corresponding powers, the exponents. Those have to match up for it to be something you can combine. Okay, moving forward, and we're getting close to the end here. I'm trying to make shorter videos that are more focused. So this one is just how many x's are there in this expression. Okay, and they're not saying count the x's like 1, 2, 3, 4. There are 4 x. No, that's not what we're trying to do here. We want to add them together. There's 7 x's here. There's minus 4 x's here, 1 x here, minus 10 x's here. What is it all together? And what we can do is, because they're all the same exponent, they're all the same power, we can combine them just like we're adding. So 7 minus 4 plus 1, because this is a 1, remember, minus 10. Well, if you do all that, then you have 7 minus 4 is 3, plus 1 is 4, and then 4 minus 10 is minus 6. So when I combine all of this together, it's going to give me minus 6x. Okay, the x is still there, it doesn't go away, but all the numerical coefficients, all the things in front, you can add them together, combine them, and it makes it a whole lot easier to deal with later. Okay. And now the challenge problem. So we have to simplify the following expression by grouping the like terms. Here's what I like to do. I like to circle things, and circling things for me just makes it so I can kind of connect them together and find out what's the same. So remember the rule. We're looking for things that have the same power. And I'm going to start off with the biggest stuff. The biggest stuff is usually what you put right in the front. So the biggest looking one that I see is right here, x squared y. And here's another x squared y. So I've got one here and I've got one here. Do I have anything else? No, I don't. Okay, so this is a minus 1 x squared y, and this one is a plus 7 x squared y. Minus 1 plus 7, well, that is 6 x squared y. Okay, I've dealt with these. These are all gone. Now the next biggest, I have 7xy minus 6xy. I think I'm going to do that. Minus 6 plus 7, well, that is a plus 1. So I have plus 1 xy. And since it's just plus 1 xy, I can actually just say plus xy. Okay, those are dealt with. Next biggest stuff, I have minus 6x, 3x, and 7. So 3 plus 7 is 10, and then I have minus 6. So that is a total of plus 4x. And lastly, I have my coefficients, or sorry, my constants. I have 14 minus 18 is minus 4, and then minus 5 is minus 9. So if I have put them all together, that is my whole expression. It means exactly the same as this gigantic mess right here, but it is combined with all the like terms, and it's going to be easier to deal with later. Not that you have to deal with x squared y, xy, but someday you will. Okay. Like terms continued. I think we've got a bit more to go. This is going to be the longest one. Okay. If you want, this is a really good place for you to pause this video and try this out on your own if you're feeling comfortable. And then I'm going to solve it for you, and you can see whether you did it correctly. So go ahead, pause the video, try it out. Okay, to solve this, I am going to look at the biggest ones. I have minus 9x squared y, and I've got x squared y. So that's minus 9 plus 1. That gives me minus 8x squared y. Next biggest is my 4xy and my minus 5xy. Minus 5 plus 4 is minus 1. So that's minus xy. That's gone. Next biggest is just my plus xy. I don't see anything else here, so I can just go plus xy. Anybody notice a mistake I just made? Hopefully you did. I missed a like term. So I had 4xy, and I had xy. Nope, not that one. And over here, I had minus 5xy. So the mistake I made is that I had 4x minus 5x, but I did not see that one. So when I'm looking at this again, I get minus xy plus xy. They actually cancel out completely because plus 1 and minus 1, they do cross themselves out. And you can see that with 1 plus 4 is 5, minus 5 is 0. So there's nothing left. These are all gone. They just cancel each other out all out. It's real nice. And lastly, we have 5 minus 2 is 3. And then 3 minus 10 is minus 7. So your answer should have been this. Okay. Next one, we have x squared and we have x squared. Anything else x squared so I don't make any more mistakes? No? All right. So let's combine them. Minus 1x squared plus 3x squared is 2x squared. All right. And next I'll do is just my x's. So usually the rule is the bigger the power, the further left you'll put it when you put it together. Also, when you have different variables, you'll usually put them in alphabetical order. So that means that the x will come before the y if they're the same power. Okay? And that's why you see me writing it like this. But it's not like it makes a huge difference. It's just you'll get used to seeing it the same way, so you might as well start earlier. So 2x squared we've already dealt with, and now we have the x's. 1x minus 4x is minus 3x. Those are gone. Oh, look, I missed one again. Way to go, Mr. E. Let's try that again. We have x minus 4x and x. So that comes to minus 2x. All right. Quick question. Can I do 2x squared minus 2x and that just cancels each other out? The answer is no, because they have different powers. That's the power of 2 and this is the power of 1. They cannot be combined. Great job. I know you got that. Okay, now I can move on to my y's. I have minus 6y minus 7y. So that makes minus 13y. And then lastly, I just have a plus 4. And that is my final answer. Okay. Show you know. This is your turn. I know that I already said you could try one of these before. Hopefully you did. You didn't have to. But these ones you have to. These ones you need to try on your own because you need to practice it and make sure that you understand this. And if you are not getting these at this point, you can either go back and watch some of the stuff again or ask me. Because this is stuff you should definitely be able to do on your own at this point, just combining stuff. All right, so go ahead and pause the video, and then you'll come back and you'll see it worked out here. All right, so This is the last one that you actually need to do, and I'm just going to very quickly solve this one so that you don't have to listen to me talk and talk and talk. I'm going to start by doing this one. 4x minus 10x. So I got minus 6x. These are gone. And be very careful with the negatives. You got to be very careful with those. So the next one is my variables here. I got minus 3y. Okay, so that's minus y. And then just a bunch of numbers. So it looks like 17 plus 19. That's what you should have got for this one. All right, starting here, 4 minus 12, so that is minus 8xy. Here we have minus 2x, minus 5x, so minus 7x. And then just the constants, that's 16, and then take away that, so I have plus 9, I believe. And the last one, oh, these m's and n's are kind of doing my head some tricks here. I've got 13 and 24, so that's a plus 24, so that looks like a positive 11. Yeah, positive 11 mn. Okay, and then we have m, because m comes before n in the alphabet, if you didn't know that. Minus 12, so that would be minus 8m. Oh, I gotta be careful with my circles. See what I did here for later? I kind of crossed off a minus. Whoops. All right, then I have my n's to deal with. I got plus 6n, and I've got minus 10n, so that's minus 4n. And lastly, I have these. I've got my plus 11, my minus 29, so that looks like it's going to be minus 18. All right, and this stop sign here means that we have reached the end of this part, which was combining like terms and just what equations and expressions are all about. Okay, so get a little practice in on this. Make sure you understand all of these that we've done, and then when you feel ready, you can move on to the next.